this is an honors class. So, all of the things that I'm doing, please stop me if they don't make sense, because again, this is an honors class, and I'm trying to treat you like an honors class, all right? We're going to do today is we're going to go over laws of limits algebraically instead of graphically, okay? So look at that face. It seems hard from those words, but it's really not, okay? To give everybody a chance, even though I don't think you need it, there will be level 1, level 2, level 3 questions, okay? I will say I'm very surprised that not surprised, I'm very happily surprised at the number of students who got 2.5s and 3s on the assessment, which I'll give you back tomorrow because I forgot to make copies. It is in the gradebook though. I told you that yesterday, right? Yeah, it's in the gradebook already. If you did not take it yesterday, you'll take it on Friday. Depending on how things go, we're catching on really quick. We might move faster than the other classes, okay? Which is perfectly fine with me. All right, I don't want to stay on graphs and algebra forever. I would rather move on to actual calculus. Okay, so what I'm going to do is I'm going to give you the rules, and I feel like I'm speaking very fast. I'm sorry. I'm going to give you the rules, and then we're going to do examples. There's going to be a level 1, a level 2, and level 3. Everybody should get level 1. This is the easiest. There's no reason why people should be failing this class. And yes, I do have people with D's in this class. No shade, but shade. Or what's the thing? Sorry, not sorry. Okay? We should all be getting at least 2s and 3s, if not 4s when we get to those levels. Okay? All right, let's get started then. Today is the 25th. I think I've been writing the 24th and everything, by the way. We're going to be calculating limits. Limits algebraically. The first 3 rules that we're going to use will only be used, I'm sorry, nix the only, will be used for level 1, but we can also use them for level 2 and 3, okay? When I get to the level 2 and 3 rules, they are not used for level 1. So these will not only be used for level 1, they'll also be used for level 2 and 3. Okay, so these are level 1, 2, 3 laws, but again, I'll just say it when I get there. Sorry. Level 1 and 3 laws. I'm going to give you the law name and the mathematical rule. Okay? So the first rule I have is the constant rule. In math. Sorry. I need to slow down. In math, what is the definition of a constant? In math, what is the definition of a constant? Don't know?
Something like a fixed rate.
That would be a constant rate, yes. But like, it's a fixed thing, right? What else in math? When we're talking about like equations, what is a constant? Nope, not the pen drop or pencil. That's okay. A constant is a number without a variable. Okay, do you remember that now? No? Y equals mx plus b. What is the constant? Y equals mx plus b. B, why is b the constant? Because it doesn't have a variable, okay? So, the constant rule is going to be with things that don't have a variable. Wow, that was like pulling teeth. No laughs on that. Wow, we need to, either I need to get better jokes or like we just need to liven up in this class. No, let me not say that. I'm actually getting through things because somebody's not here. Okay, so this says the limit as x approaches a, where a is going to be like some number of some constant, so this is the constant, is going to be that same constant, okay? This is a number without a variable, a number without a variable. Graphically, I know we've been doing graphs, so let me show you what it means graphically. So let's say I have y equals k here, and I'm looking at a. When we're doing limits on a graph, we're looking to the left of a and to the right of a. So if I move along the graph and I get to this point k, and I move along to the graph and I get to this point k, the limit is k because both sides of your graph approach the same value. Okay? So this is numerically and this is graphically. All right. Am I going too fast? No. Yes? How fast am I going? Like, honestly. If I'm going too fast, just please let me know. Somebody says yes, and then you guys bully them into... linear. Jahir, did you go? No. You gonna go? Brian? Linear says the limit as x approaches a of x is equal to a. What? Am I going too fast? Okay. So if a was a number, let's say 6, then the limit would be what? 6. What am I doing mathematically between a and x? What do we think? Mathematically, what am I doing? Starts with an S. You usually use the word or phrase that starts with a P. Starts with an S. Oh. I am substituting a into x. Okay? Substituting. That's it. That's all I'm doing. Substituting. Do we all need to stand up and take a stretch? Wake up? Yes? Yes. All right, stand up and stretch for like 10 seconds if you need to. Okay, nobody stand up then. All right, let's move on then. You can't see that color. Matthew stood up? Matthew didn't stand up. All right. All right, here are level 2 and 3. Level 2 and 3. So again, for level 2 and 3, we can use these, but we are not going to use the rules that I'm going to give you for 2 and 3 for level 1. Okay? Does that make sense what I said? Can I? No? Okay. For level 2 and 3, I can also use these rules. For level 1, I'm only going to use these rules. I hope that makes sense now. All right. Like, I don't know if people really, you've got to stop being afraid. All right. I have 5 rules to give you, okay? But 4 of them are very similar, and you should know how to do this. And let's see if we can come up with it. Before we do level 2 and 3 rules, we need to give you some background. Gentlemen, you good? Okay. In order to use these rules, the following things must be true. So if we have the limit as x approaches a of f of x, and that's equal to a limit, and then we have the limit as x approaches a of g of x, and that is going to be equal to the limit. Do you need me to zoom in? I see people squinting. Is that better?
That's an L.
That is an L. This one? Yep. Yep. Oh. Two things need to be true. The first thing is as that they have to approach the same value. To use these rules, they have to approach the same value. Have to. If one is 6 and one is 7, you cannot use these rules. They have to approach the same value. The other thing is that the limits must exist. The limits must exist. One of them can't be 0 and the other one does not exist. You can have a 0 limit, you just can't have does not exist because you can't use these rules. Okay. The first rule is the addition rule. The addition rule says that if I have two functions added together, approaching the same value, I can add their limits together. So that's in words. So the limit as x approaches a of f of x plus g of x. I can split these up so that I can calculate them separately. I can split them up so I can calculate them separately. Because there will be times when it's easier to split them up to calculate them than it is to keep them together. So we have the limit as x approaches a of f of x plus the limit as x approaches a of g of x. Am I off screen? Thanks. So I'm splitting them up, f of x, g of x, f of x, g of x. In some cases, you will know the limit, and you'll see when we get to level 2. So you'll have the limit 1 plus the limit 2. Limit 1, limit 2. Questions? All right, what do we think the next law is? Subtraction. Somebody tell me what the law would be. What do we think it's going to be? Okay. I heard somebody say lim. Okay, f of x minus g of x. Very good. Who is that? Very good, very good. But what is missing? Very good. And then what's that going to equal to? Very good. Come get a sticker. No? You don't want one? Okay. Do you want a stamp? You sure you want a sticker? It says math is cool. Questions? Can I move? No? Here, let me do this. Let's do this. All right. What do we think the third one is? Multiplication. So this one is going to be, or not to be, what? Somebody say something. All right, what is it going to look like? F of x times g of x equals Do you want to teach the class? Sure. I'll give you a cookie. Thank you for laughing at me, by the way. I don't mean like at me, but. All right. What do we think number 4 is? Division. A. So what's that going to look like? Okay. Oh, I'm running out. Hold on. Okay, go ahead. What are you missing? Very good. Look at you. Is anybody not understanding what she's doing? Do we understand this? Without examples, do we kind of understand it? Just imagine the limits are numbers. We understand, I'm hoping, addition, subtraction, multiplication, and division. I'm hoping. Okay, thanks. Can I go down? Are we sure? Looks like some of us are not used to writing. All right, the last one. Can we see that color? Yeah. Okay. This one you won't know. Or do we think we know which one this would be? No? That's okay. It's going to be the radical / root law. What this one is saying is that if I have the limit as x approaches a of the nth root of f of x, I can just take the entire limit underneath that root. That's the last rule. Oh, sorry. When you're done with that, I need to talk about number 4. You will. You will. But you can't solve it like this with a function. You have to like get a number. Okay? And I think you mean simplify.
The x a is supposed to be outside of it in the first one?
Yes. So all it's saying is that you can find the limit before you take the root. Okay? So mathematically, you don't have to write this down, but mathematically, the nth root of something is just the, I don't know if you guys did this last year, is the 1 over n root. So then you can take the limit of this and then take the root of it. Okay? I don't know if you guys did that last year. Okay. All right. Are we done copying this down? No. Like for real, no? Or you trouble? No. Was that you, Amelia? Oh. When you're done copying this down, take out the worksheet that you picked up. You can decide one of two things. Whether to write your notes on this worksheet or in your notebook. I don't care. If you write big, write it in your notebook. If you want to save space and not write in your notebook, I don't care. Write it where you feel comfortable, okay? Let me know when you're ready, Amelia. You good? No? Maybe? So rude. I'm going to do that next time you ask me a question.
I'm good.
Okay. All right. Okay. All right. I want to show you the difference between. First, let me do level 1. I'm going to do level 1 kind of quickly, but I'm going to do it on here, and I'm not going to rewrite the problem, okay? I'm not going to rewrite the problem. Well, I have to. No, I'm not. I'm just going to put it on here. So if we look at example 1 is the constant rule. How do I know that I have a constant? The 7 has no variable. Is that what you're going to say, Amelia? 7 has no variable. So the limit is just 7. That's it. There's no x to substitute in. It is just that number. Questions? This is why level 1 is the easiest and attainable. There's no reason they should not get level 1. Level 2, or number 2, is the linear law. What am I going to do with this 2? Starts with an S. Substitute it. So we're going to substitute it in, and we get 2. That's it. Now the laws are coming in kind of clear. No, I'm sorry. Coming off of hours then. Okay. Now, what am I going to do with this negative 6? Substitute it. I only have one x, so I'm going to substitute it into there. So 9 minus 8 times negative 6. That gives me 57, and you can't see that. Double check my math. Thank you. Questions? That's level 1. That's all you're doing. Level 1. So nobody should get less than a 1. Was 1 a 73%? I don't know. Nobody should be getting less than 1. Are we good? Can I move on? Okay. The difference between level 2 and level 3 are as follows. Level 2, they're not going to give you the function. I'm not going to give you the function. I'm going to give you the actual limit. So I'm going to tell you the limit of f of x is something. The limit of g of x is something. And so on and so on and so on. Okay? Level 3, you don't have the limit. You have the function. So you're going to have to make sure that you're substituting it in correctly. Capiche? Capash? No? Okay. That's okay. Look. So this one, they give you the actual number. Okay? This one, they give you the equation. So you're going to need to use these numbers here to find the number. Okay? Better now? Okay. All right. So let's do this one. So this is level 2. We can see that the limit of f of x is 2, the limit of g of x is negative 4, and the limit of h of x is 0. Okay? We're going to use these 3 things to solve these 6 problems. Got it? Okay. So, I have f of x. So I can take the limit as x of, this is why I should write it on a different piece of paper. No, sorry. That should be a plus sign. So I'm going to separate them. Now you see why I said you should put it on a separate piece of paper? Okay. I'm going to substitute in what I know. Do I know what the limit of f of x is? Yeah, what is it? 2. Do I know the limit of g of x? Yes, what is that? Negative 4. But what should I do then when I get negative 4? Multiply by what? 2. How do I know I'm going to multiply by 2? There's a 2 in that g of x. Remember, in math, I can take a coefficient and move it to the front. Okay? Because 2 times 3 is the same as 3 times 2, right? So I can move it to the front. And that's where I moved it. Does that make sense? And now you just simplify. Mathematically, or if I did my math right, that's negative 6. C or no? Yes, okay. Are we good? Okay. Next one. I'm not going to split this up, but I want you to split it up on your assessments, okay? What is the limit of h of x? 0. What is the limit of g of x? What should go in front of it, though? And then what's the limit of 1? Plus 1. Very good. And I think that's 13. No, yes? Oh. Are we good on that? You sure? Okay. All right, the next one. What are we going to be doing? What rule? Multiplication. How do we know it's multiplication? Yes, and there's no operation. Okay? Because I can have parentheses but still have addition. Okay? So what's F? What's G? So that gives me negative 8. Questions? Oh, sorry. When everybody's done writing that down, take your notes back out. Yeah, I know. I'm sorry. I forgot to give you one thing. All right, going back to DISA 1. What can we never divide by? We can't divide by 0. So we have to make sure that for division, L2 does not equal to 0. Sorry, I forgot that. So just write that little caveat. Write that little thing. Sir, wake up. All right, can I move on to the next one then? Do you mind if I go over a harder one for level 2? I'm assuming nobody minds if I go over the harder one. Okay. I'm going to skip 4 and I'm going to skip 6. All you're doing is substituting in and simplifying, okay? I do want to talk about this one right here. Actually, I also want to talk about this one. Actually, let me go here. Okay. What is the limit of g of x? Negative 4 squared. All right, seniors, if you don't listen to me all day, that's sad, but I need you to really listen to me now. Can we grab our calculator? And I want you to type this into your calculator. Exactly like this. Exactly like that. No prints. Exactly like that. Negative 16. Now, type it in with parentheses. Are they the same number? No. Not what? Owing $16 and having $16 in your pocket is not the same. Okay? This is 16. Seniors. for the love of all that is holy or whatever your religious preference is, please use parentheses. Please. -4 squared in the calculator without parentheses will be calculated as exponents first and then multiplying by -1. Use parentheses. Capiche? Thank you. Okay, that's why I wanted to go over that one. Now let's go over number 5. Do I have to split you two up? We have the cubed root of 6 plus what? 2. Which gives me the cubed root of 8. Without a calculator, what's the cubed root of 8? 2. Look at, Amelia, you want a sticker? So I bought all these stickers and nobody wants them. You didn't answer a question. I'm not giving you one. Do we know how to put this in our calculator? No? Okay. Yeah? We sure? How do we do it? Because that's square root, right? If you don't know how to put it in your calculator, hit math. Hit math. Push the math button. How about that? Is that better? Push the math button. Number 4 is the cubed root. Right? And then put 8 underneath. And then hit enter. And you should get 2. Okay? If you don't have a square root, or if you don't have a cubed root, what you're going to use is number 5 and replace the x. Okay? But we'll talk about that later. We're not going to do this right now. Cool? Yes, no, maybe so? All right. All right, seniors. I'm just going to go over a couple examples for this one because I see a lot of us are being checked out, and I know today was a lot of notes, but I needed you to get these notes in order to understand the material. I didn't want to split today's notes up into level 1 and 2 and 3 because they're all the same thing, okay? That's why we have a little bit more notes than we usually do, okay? All right, so let's look at this. So now, the difference between level 2 and 3 is that you have to actually find the limit for these, okay? And this is where splitting them up will come into play and to help. So let's look at this. We have the limit as x approaches 0 of f of x plus g of x. So I'm going to split it up. Am I talking too fast? Okay. So I'm going to split it up. The limit as x approaches 0 of f of x plus the limit as x approaches 0 of g of x. Now, you want to split these up because they're different functions, and it's going to be harder sometimes for you to do it together, okay? So, I'm just going to draw a dotted line so you can see the difference between what I'm doing for f of x and what I'm doing for g of x. Is that better? Can you see this better? Yeah. Okay. So, f of x was 2x minus 1. So I'm going to take that 0 and substitute it in. Let me write the plus. So we have 2 times 0 minus 1. Okay? And then I'm going to do the same thing for g of x. 0 plus 1 squared. I'm just going to do my math in my head. This gives me 1 plus negative 1 plus 1. And negative 1 plus 1 is what? 0. So the whole limit of this is 0. Honestly, is this hard? Okay. Can I get a show of hands of who wants me to do another example? Okay, I'll do one more example. Do you want me to pick a specific one, or do you have a specific one you want me to do? 3? 3? Okay, let's do 3. Oh, that's a good one. Okay, let's do 3. Oh, I'm sorry. Did everybody have this down before I moved it? Good, good, good. Okay. Okay, let's do 3. So I'm going to split these up. So I'm going to have the limit as x approaches 1 of x, I'm sorry, h of x over the limit as x approaches 1 of g of x. Okay? That's an h, FY. That's an h. Oh, not g of x. What was that? J of x. J. We're going to need more paper. Okay. How you do this one depends on you. You can do the h of x on the side, and then you can do the j of x on the other side. You can do one on top of the other. I don't care. Just make sure that you're doing them separately. Because if you put them into your calculator and you don't know how to work your calculator, or you're sleeping the entire time I'm showing you how to do this, you're not going to get the highest amount of points. Okay? All right. So I'm going to substitute in 1 for my x's. Can you see? You cannot see what I'm pointing at. I'm going to substitute in 1 for my x's. Okay? I'm going to do h of x on this side. So it's going to be 1 plus 8 over 1 minus 2. Thank you. So then the limit, let me write the limit, as x approaches 1. The limit as x approaches 1 of h of x is -9. Okay? Questions on that? Are you sure? Okay. So that's going to be my numerator. That will be my numerator. Then I'm going to do j. Let me see if I can zoom out a little bit. Okay, there. So the limit as x approaches 1 of j of x is going to be equal to the cubed root of 1 minus 9 is equal to the cubed root of -8, which is what? I'm off screen. Which is what? I'm sorry, you guys are probably still writing this down. Why don't you, just let me know that you're still writing this down. -2. Okay? So that will be my denominator, and that just becomes 9 over 2. Questions? Are you sure? Okay. You guys